Hey friends, welcome to Congruence Tutorials. In this video, we will solve this differential equation. We will learn how to solve this equation. This is a homogeneous equation in x and y. So we can do this by an easy substitution. X upon y equal to b. Or in some questions, you may also get y upon x. So in that case, y upon x equal to b. So over here we'll take x upon y equal to b. So the differentiation of this this will be, let's say first write down x in terms of v and y, v into y. Okay, so differentiating the above with respect to y, we get dx upon dy equal to v into 1 plus y into dv by dy. Chain rule. Okay, so the differentiation of this term will be, differentiation of x equal to v into y will be dx by dy into v into 1 plus y into dv by dy. Okay, we'll keep this aside. Now coming back to this main question, 1 plus e x upon y plus e x upon y 1 minus x upon y dy by dx, right, equal to 0. Now this can also be done by substituting x upon y we have taken as v, right? So we put v here, and then this dx by dy here, instead of dy by dx we have dx by dy we have found. So we'll first multiply this equation, this entire equation, by dx upon dy, so that dy by dx will get cancelled from here on this side. This side will remain 0. So dx dy, so both of them will be cancelled, and here we'll have dx by dy. So let's write this down. So dx upon dy will multiply this equation, okay, if you did not see earlier. So 1 upon e raised to x upon y upon x dx by dy plus e x upon y 1 minus x upon y d is sorry, here it will not be dy by dx anymore, equal to 0. Okay, so this has become our question now, right? So now we can substitute 1 plus e v, here we have 1 plus v plus y dv upon dy plus e v 1 minus v equal to 0. Correct? We expand this bracket now. So we have v plus v e raised to v, correct, v plus e raised to v plus y right. Plus open this bracket, ev minus v e, right? Now let's see what happens. Okay, v into 1 into v do v into e raised to v here. Okay, so we've kept this bracket as it is, we have not opened this bracket. So next term will be y into 1 plus e raised to v into dv by dy. I'll tell you why, we have not opened it. So now this bracket we opened, ev minus v into e raised to v, so because these two gets cancelled. Okay, So final question, so your next step will be v plus e raised to v plus y 1 plus e raised to v dv by dy equal to 0. Clear? Now you can see that we can differentiate, that we can separate the variables easily, right? So now we can just throw this term on the other side, this one. So y 1 plus e raised to v dv by dy equal to minus v plus ab e raised to v. Okay, and then finally rearranging the terms again, dv will keep this side, we get 1 plus e raised to v upon v plus e raised to v dv equal to 1 plus e raised to v dv v plus e raised to v, okay, plus dy goes here and y comes down here, so dy upon y. Cool. So next is pretty easy. Next step is pretty easy. So let's just write this entire thing down again. We had 1 plus e raised to v dv upon v plus e raised to v equal to dy upon y, right? And then we integrate it. So if you observe differentiation of this term, e raised to v plus v d of dv ev plus v is equal to nothing but ev plus 1, which is nothing but the numerator, right? So we'll do put ev plus v equal to u, therefore du equal to ev plus 1 dv. So this term we can write down as du. So this becomes integration du upon u equal to minus dy upon y. We had a minus sign here, if you remember. Correct. So ln u equal to minus ln y plus ln c. Okay, which can be written as ln u equal to ln of c minus ln of y, ln c minus ln y equal to, by logarithmic properties we have ln of c upon y ln u on the right side, left side. Now we can take anti-log because this is ln one term, so we can write down u equal to c upon y. U is what? ev plus v equal to c upon y, correct? So put our equation back in here. What was v? V was x upon y. So put back in the equation. Pardon my handwriting. E is to x upon y plus x upon y equal to c upon y. Or we can further simplify it by multiplying y on both the sides. Y is to x upon y, so this y will go away, so it will remain only x, and here remain only c. So this is our final answer. Okay.